Push that rock with Simpson Math. Let's look at a definite integral for a fairly complicated function. In fact, one that looks like it might require parts. If I think I need parts, then I ignore the definite integral and just go get the antiderivative, which means I do an indefinite integral. And I think I'm going to need parts here. So I need an f and I need a g prime. And Lie-8, remember the little mnemonic device? At the top is an L, so I see a log, so I'm going to let that be my f. That's going to be my natural log of x. Well, then my g prime has to be the other function. And you might think it's square root of x, but hold on, it's in the denominator. So it's actually 1 over the square root of x, which is the same thing as x to the negative 1/2. Right? You have to be able to see this function in here as two functions multiplied together. So there's the natural log of x times x to the negative 1/2. It's supposed to be a negative 1/2 up there. That's terrible. So anyway, so now I'm going to get the derivative of this. So that's easy, vanishing log rule. And I'm going to get the antiderivative of this, and I can use power rule. Add 1 to the power, you get x to the 1/2, and put the reciprocal out front. So the parts formula says take f and multiply it by g. So I get the natural log of x multiplied by g. Well, I'm going to do g times an f because it's more polite to have this in front of the natural log, minus the integration of f prime times g. So I have 1 over x times g x to the 1/2 dx. Now, sometimes you need u sub to get out of this. Sometimes you need parts again to get out of this. But in this time, we just need to simplify and use the power rule. I mean, this is a straightforward, easy one to do. I'm going to clean this up a little. I'm going to call this 2 square roots of x times the natural log of x minus, I'm going to rewrite that as 1 over root x times root x, because root x times root x is x. Meanwhile, I have times 2, and x to the 1/2 is root x. And that tells me, oh, I have a square root of x here, a square root of x here. I can just reduce. And so guess what? I have 2 over the square root of x. Well, we just had that situation without the 2, so I kick the 2 out. Rewrite this 1 over the square root of x. Well, maybe I'll do it on my next step. Dx. So here's what we have so far. Okay? So we need to integrate this. Well, we just did it. We already know that if you integrate 1 over square root of x, it comes out to be 2x to the 1/2 or 2 square roots of x. So I already know that. So I know that this is going to become 2 square roots of x. So there is my antiderivative. Don't forget your plus c, except that the whole reason why we went and got this antiderivative is so that we could do a definite integral. So you can do the definite integral with any antiderivative. So I'm just going to let c be 0, and that's gone. So here's our antiderivative. Let's go back to the other problem. So the other problem is 2 root x. The antiderivative for the other problem is 2 root x times natural log of x minus 4 root x. So, can't quite see the problem there. So we're going to have 2 root x times the natural log of x minus 4 root x because of the 2 times 2. And remember, it's a definite integral from 1 to e. So we evaluated at e first. So that gives me 2 square root of e times the natural log of e minus 4 square roots of e. Minus, open up your bracket because this is a polynomial and you're subtracting, put in your 1. So 2 square roots of 1 times the natural log of 1 minus 4 square roots of 1. That's the fundamental theorem of calculus, or the evaluation theorem. You evaluate the antiderivative at the upper limit of integration, boom. You evaluate the antiderivative at the lower limit of integration, boom. And then you subtract, and that's why these brackets are so important. So here, the natural log of e is just 1. That's just a fancy way to write 1. So I have 2 square roots of e minus 4 square roots of e minus, in this bracket, The natural log of 1 is a fancy way to write 0, and 0 times anything is 0. So I have a 0 there, minus the square root of 1 is just 1, so that's a minus 4. So what do I have? Well, 2 of something minus 4 of those things. If I have 2 apples, somebody takes away 4, well, I'm 2 apples in negative land somehow. I guess I owe them 2 apples. So I got negative 2 square roots of e. And then I have minus this negative 4, so I have plus 4. And so you might write it more politely, 4 minus 2 root e. But that is the value of this definite integral. And if you think of it as the net area under this curve, then it's the net area between the curve and the x-axis in square units. But we weren't told to solve an area problem. We were just given this definite integral. So the definite integral is equal to 4 minus 2 square roots of e. Math made simple at Simpson Math.